friends. How are you doing today? And we are here with Fred Silverberg and Bill Wagner visiting today on the .NET Languages and Runtime Community Stand-Up. So thank you all for being here. Today we're talking about how we communicate about C#, places that you can go to find out more about C#, and ways that you can engage with us on the whole pipeline of conversation. We're also super looking forward to your questions and comments. So please feel free to use the chat to reach out with that. And I'd like to start by introducing all of us. I'm Kathleen Dollard. I'm a program manager on the .NET teams working on the three managed languages, C#, Visual Basic, and F#. And Fred, can you introduce yourself this morning?
Yeah, my name is Fred Silverberg. I'm a compiler developer on the C# team, and I'm also a member of the C# language design team, and I'm the note taker for the language design meetings. So if you see notes online, they're generally being posted by me.
And Bill.
And I'm Bill Wagner. I am on the .NET Docs team and primarily responsible for the managed languages as well, C#, F#, VB. And also a member of the ECMA C# Standards Committee. So work on that part of the docs related to the language. So there we are.
All right. Well, let's get going. So we are all part of the language design. We call it the language design meeting, or the LDM. It's actually a team. That's a little bit confusing, but Microsoft does that sometimes. So this is a group of people that get together about 4 hours a week. And we also have special meetings. Smaller than that, there's a huge amount of investment in the design of C#, so that by the time it gets to you, it just looks easy. Believe me, it's not always easy behind the scene. So Matt came and talked to us some about the kind of the process. So I'd like to focus a little bit more today. We can talk about C# 11 some. I'm working on the blog post that should have already gone out, and I'm hoping to get it out Monday about the new features that are coming up in the preview 3, which is just on the streets right now. In the 17.2 preview 3 contains C# 11 preview 3 if you want to take a look at that. But I thought we might start, Fred, until we get some questions about the notes. Some things about the notes, how you think about that. There's this little thing at the top, quote of the day. Where does that come from? And talk a little bit about your processes to communicate about the notes in that.
Sure. And I will say LDM versus LDT, I have to rationalize very hard in my head when I'm writing things. Okay, do I use which acronym do I use right now? Which one makes sense? But in general, my process for writing notes is I take a shorthand form of notes during the meeting. Just not even full sentences, just like XYZ. We like this thing, we don't like that thing. I try and then we also do general reads in the room, as we call them, trying to gauge sentiment in the LDM, and those are actually recorded in Teams, so I don't have to take notes on those. I can just go back and look at them. But generally, at the end, I take all of my raw, unintelligible to anyone but me information, and I type them up. And you can find that information at github.com/.net/CSharpLine/meetings. And I've been doing the notes since about mid-2019, I think, when Andy left the team. And so I type up the notes. The only thing I take down verbatim generally is when someone says something funny. And those are the quotes of the day. And sometimes the LDM is in fine form, and I have to give multiple notes of the day, or quotes of the day, because sometimes they're funny.
Yeah.
And then sometimes I have to struggle to I have to like trick someone into saying something that gives me a quote of the day.
Right. So if we trace our information about a feature, if you want to learn about a feature, if we trace it, then before something can come to LDM, it has to have a spec we think about like the equivalent of a spec. It might be a speclet. It occasionally is a proposal or a spec. Sometimes it is actually just a really written out issue that has everything captured in the issue. So that's where it starts. So we're not just talking about random things in LDM. It's very scheduled. Generally, an issue gets an hour there. And so then we generally do about 4 issues a week. Issues sometimes have to come multiple times. Occasionally not, but I think it's more often that something has to come multiple times than it only comes once. Then it goes into the feature status, and that's actually where Bill and I can first pick it up. And I'd like to let Bill talk a little bit about some changes that we're making around docs, if I'm not putting him on the spot too much, because we're just starting these changes and we always hate to talk about things before we can say, go look here. But we don't want to wait till November to talk about C# 11. We want to start talking much earlier than that.
Yeah, so this is something we're changing because of how we're handling how you can get previews. If you go back, say the last 2 or 3 releases, the only way you were going to be able to get to use C# 11 in preview form would be to download the .NET 7 SDK and use that, or use that in the appropriate Visual Studio preview. Now, it is getting bundled into the updates of the .NET 6 SDK if you set language version to preview. So even if you want to stay on the same SDK, you can just on a project by project basis update your language version. So that gives you the chance to try some of the features. So with that, what I've been working on doing, and I'm still a little bit behind, is there's already a what's new page for what's in C# 11. And I'm adding features as they go out in public previews so that you could try them if you turn on that preview flag, or if you do want to use the .NET 7 previews. And that way we can get earlier feedback around those and make better decisions and possibly tweak the features between now and November.
And Bill and I have been working together to, as the PM, one of the things that I'm extremely interested in doing is increasing the number of people and the kinds of people that are giving us feedback on our previews. And what I mean by that is that we love the folks that talk to us all the time. Absolutely, that's fantastic. But we also want to broaden that reach as far as possible when we're getting feedback on features that everyone is going to use. So we're trying to lower the bar as far as possible. We have already done that in that we put the preview features behind a preview flag in the compiler. So if you're in the preview version of 17.2, then you can work with the C# 11 features. And actually, since you're in a preview, in that case, you don't even have to use the preview flag. Because depending on the changes that we're making, we can't always support that in the previous version of Visual Studio. And I don't think that we can use C# 11 features in 17.1. 17.2 is the next version of Visual Studio that's coming out. So that work has been done, but from there, the next step is making sure you understand the feature enough to be able to actually use it, see what we wanted to accomplish, and tell us whether we're accomplishing that. And that's where Bill comes in this change to the what's new being done during the preview cycle, not at the end of it. So, yeah.
And then one other change that we're adding there, which primarily is just filling a hole. I had a page that had breaking changes in the compiler that talked about the most recent breaking changes and then pointed to the docs in the Roslyn repo that describe exactly what, when there is a breaking change that gets added. What we're doing now is I've been working with Fred and others on the compiler team, and the extra information I would add in docs, namely why you might run into this, what you would do to work around it if you do run into it, they're adding, and why we actually accepted this break. They're adding into the page in the Roslyn repo, and on docs, we're basically just pulling in some assets from the Roslyn repo and publishing them there. So there's now a single source of truth, and it's much less likely I'll miss any of the breaking changes, because we're publishing it directly from the Roslyn source.
Great. Okay. And then the third part of the circle is the blog post, which we're going to put out, but the blog posts in the future can just point to docs And so we won't be doing this redundant, here's how you use the feature. Well, here's how you use the feature again. And hopefully, hopefully the blog post will be a little bit more interesting because it can point to docs on some of the features that are a little bit more complicated. So, yeah. We do have a question. I think we don't have a good answer to this question, but I would like to go ahead and bring it up and ask it. Plans to add features to C# to make writing, particularly MVU apps, easier. I don't know of anything that we have on the table right now. I would really encourage you, Fred.
Yes. So I've been doing some thinking on this.
Oh, great.
Yes, and in particular, we've been talking about for the past, especially now the past couple of years, we've been talking about roles and extensions. And I think there's opportunity, and I'll actually link. My cats are hopefully. I don't know whether you can hear the buzzing from my cats playing with a toy in the background right now.
I
No?
can
Cool.
hear it.
All
I
right.
think
It's
you're
really
right.
loud. It's really loud here, but I'm glad you can't hear it. Anyway, so roles and extensions gives us an opportunity to potentially make that easier and basically use collection initializers and object initializers for everything. So we've been talking about improvements to that, and in particular, let me link this discussion that I opened for target typed object initializers, which basically allow you to have customizable properties available at specific sections of an object creation, which could then be used for MVU. And so you could say that, oh, this grid is like if this child is an element of a grid, then I can set like which row and column it is as object initializers with just because it is the child, just because it appears below a grid object when it's being newed up. So I think there is some opportunity. I don't know whether I mean I don't. It's not going to be in C#11. It may not even be in C#12. But it is something that we are thinking about.
So we can talk a little bit more about roles and extension because we definitely, I mean, this whole conversation to me today is about communicating what we're doing in C#11 and how people can be connected with us for that. And so roles and extensions is not C#11, but it's definitely something that we're thinking about. So can you give a succinct explanation of our thinking, Fred? I can give a long one, but I'm afraid it would wander more than a little bit. I mean,
A
let's, yeah.
role is a view. It is a way to take existing data and view it in a new way, possibly implicitly, possibly explicitly, such that you don't change the data, but you add new capabilities to it. So if something is the child of a grid, for example, you add the ability to say this is the column and the row in the grid. Whereas behind the scenes, that's implemented via property bag as traditional UI elements work. But when you're working with it, you don't want to be manipulating a property bag by hand. You want to just say, I want the grid column. And that's what roles kind of lets you do.
Okay, so you're using the word data here, and from the point of view of C#, that's just a instance of a type, and extra things that are attached to the instance of the type. Is that correct?
Basically.
Okay, so yeah, so data just in our world from a language perspective. So what's the difference between roles and extensions?
Role is explicit, extension is implicit. So an extension basically lets you it lets you define things that apply to every instance of a type, and roles are like, I want to treat this instance specially.
All right. So one's more of an instance and one's more of a type change?
Yeah.
Okay. All right. So let's yeah. Okay. So have we had any more questions come up? Nope. Okay. That's great. So shall we look at some of the C#11 features, or talk about them a little bit? The ones that we just announced. So that would be rostering literals, and UTF-8, and I can bring them all up. The ones that are in Preview 3. I think the only thing we want to talk about is those that are in Preview 3, which are those two. We have a little bit of a performance enhancement. So actually, before we go to that, I'd like to talk about the notion of why we make changes. And we've been working on articulating that a bit. And we do it for 4 reasons that are pretty distinct. And that's productivity, and that makes it easier for you to write code and then to understand code that's already been written. Resiliency, which means that your app at runtime is less likely to crash. That's what resiliency means, and more likely to do the right thing. The third is performance. We work on performance explicitly. What we care most about is the performance of your application at runtime. So we work closely with the BCL on those issues. And then finally, we have some new scenarios to work out. So as we go ahead, 4.
We have one more bucket, which is developer productivity.
I thought that was my first one.
Well, I heard resilience first.
Okay. At any rate, yes, it's number 1. It's number 1, helping you write code better. Better code, faster, easier to understand. We use understand instead of read because it's like, reading words doesn't help. You have to get the whole sense of the thing. And reading code, you need to be able to understand the whole gestalt of the whole thing. So something like pattern matching, which does shorten your code, and it makes it easier to comprehend a list of ifs as a whole. And that's something that we would put in the productivity bucket.
Yeah, can I leap in on that one? Because I like to describe that one differently. I think the win out of pattern matching is less about it's shorter, although that is often what happens. I think the win is, if I were to describe pattern matching to someone who's never written code, is I want to just describe how a piece of data looks. It's got certain properties. It might have certain values. It might have a certain type or a model. I'm describing some characteristics about it. And then if it matches, this is where we go. And that is all of the constructs we have around pattern matching kind of lets us do that without writing this very imperative check to see if the type is, check to see if a property is this value, and so on. Whereas we can just describe it's a red car that's built by Ford. Oh, okay. I've got some properties that I'm just going to match on. And I think that makes it very readable as well as being shorter.
I would totally agree. I think that there's several reasons it's more readable. One is that you are always comparing to the same thing at the same switch. You can nest switches, but at the same switch, you're always comparing to the same thing. So you're saying effectively, if X, whatever, is this, or this, or this, or this, or this, as you go down, which is just easier to read, and it keeps you from mixing things up. So you're not going to say if X is this, and if Y is this, and then if X is this and this. So you'd wind up without that complexity there. So that's absolutely true. But then I also do find that just the less ceremony makes it so much easier. So I think all those things together, I think pattern matching is hard to get used to, but when you see it in a place that it really fits well, it's kind of overwhelmingly positive. And I know of at least one of those places, but I don't have the link. And I don't know if you can get the link to your tutorial there. But Bill did a tutorial that's really
declarative
on the, and it's on it's a real bridge that we made a lot of pretend things about. So there is a toll bridge that goes between Bellevue and Seattle, and that toll bridge does have variable pricing based on whatever. I guess we made it the time of day and the direction of travel, but I think it may be unload. So it's not the real bridge. And anyway, this is in Docs, and if you're on the fence on pattern matching, I think it's a really good place to go to see how pattern matching can be kind of in this case, it's kind of an unquestionable win, in my opinion. And it's just like the old code is just like pages, and the new code fits on a page. You can look at it, you can read it, no problem. And Andrew Hall, I don't think he's given you a PR yet, but in our workshop at Dev Intersection, he took this a step further with the C# 10 features and made it even nicer. So I told him to give you a PR. So we'll get that updated. So yeah, pattern matching is one of these things that we've had to draw over multiple releases. How long have we been working on it, Bill?
I think the first feature showed up in C# 7.
Yep.
All right.
And
we have
then
new features in 11.
and there's new features in 11, the list patterns, which I'm just starting to write about now. There's some neat service area to cover there.
Yeah, and preview 3 introduces the comparison to span. So technically, there was a little bit of emotional hurdles for us to get over because it stretches things, but in a way that we think is so equivalent that we're going to allow comparisons of spans and read-only spans of car against literal strings. So you will be able to, which is really going to be, it's much, much nicer. Avoid you having to wrap things up and cast them. And so it's that's a super nice feature. So we have 2 new features already in C# 11, still adding to patterns. I keep thinking we might be done one day, and I don't know.
It feels to me there's 2 more broad sections of patterns to explore.
Okay.
There's indexer patterns that would let you match against dictionaries pretty easily, and then there's probably active patterns, which if you're familiar with them in F#, is basically a way to write your own pattern matching. So you could say, like, if this string can parse into an int, then do something with that, and that's pretty cool. And after that, I don't know as though there's really any more patterns to do.
Well, the thing is, we do active patterns. It changes the responsibility for who's writing it, but then you can kind of write anything on your own with actual patterns.
Yeah, and that's the thing, right? We want to add stuff to C# that everyone is going to use. We don't want to make pattern matching a bloated thing that can do everything under the sun. If you have a more specific use case, we want to enable you to be able to write it. But we don't need to add 500 different patterns that everyone needs to remember how to use this specific thing. It gets too complex.
Absolutely. Now, in my mind, active patterns, one of the things they do is it blurs the line a little bit between kind of some notions around equality and some notions around patterns, which I think is interesting because it often is like a conversion and then a comparison and things. So it is a big step, and we have not decided that we will do it.
Yeah, this is my personal thinking. This is not what the whole LDM agrees on.
Right. And I love exactly how it's done in F#. I think it's an absolutely brilliant feature, and especially when working with complex things like against the Roslyn syntax trees, it is absolutely brilliant to be able to do a simple match instead of some complex thing that looks at attributes and figures it out. And it's not long; it's just complicated. And to be able to turn that into just is it this? And it's just super, super nice. But if that's the kind of feature that you like, definitely make an issue on C#Lang, or the discussions on C#Lang is even better, or find one and weigh in, because we definitely count. We look and see how many people are responding to something.
So we do have a few questions, Kathleen, if we want to
those.
go over them. So the first question that I saw was, is there an advantage to referencing the latest Microsoft .NET compilers.toolset NuGet package? And the answer is not really, unless you have a specific feature that you want to use at a specific point with a potentially older SDK, which is not really a supported scenario, to be clear. Then no, there's not really any advantage. I wouldn't recommend most people do it.
Mm-mm.
We also had a question on Blazor I want to acknowledge, which is we're not able to answer that question. So the question on Blazor, what's in the bag for Blazor? We're not people for that. Want the ASP.NET Standup for that, or if you have any trouble reaching out and finding somebody to answer your questions, one of us can help connect you. But we will not be able to answer that question. Mm-hmm. So we can go on to the next question.
Okay. So are there plans to make the new keyword optional in C#? Not as far as I know.
Yeah. There are no plans. I can say there are no plans with confidence. I do not have my head around how that would work. Do either of you have an idea of how we could make the new keyword is never used in F#. So there's not a intrinsic all languages need new keyword. And there's other languages that don't use it as well.
Yeah, it's potentially possible. There's some interesting cases that would require disambiguation. And the way overload resolution might work in some cases is probably pretty annoying. Like if you have a type that is named f and you have a local method that is named f, and you call f1, what happens? I don't know. There's a lot of dragons there.
Well, and I think method group conversion comes up. I think there's going to. I don't know.
Yeah. I have to say on this one, every language builds on its history unless it decides to throw it all out and start over, which we are not going to do with C#. We have the ability to gain wisdom from a language that tried that, and it caused a lot of pain for a very long time in the Python community. That the change, it wasn't throwing everything out, but that a change so big that it was a difficult hurdle to cross, far more than the .NET framework to .NET Core transition. And people just really, a lot of people didn't make that. It took what was it? Do you know, Fred? Was it 10, 12 years before they could finally stop supporting the two? And there's still people using it, but it's no longer supported. So so we're not going to take some massive, hatchet change. Short of that, we're all sitting here going, we do not know this is possible. It could be this is absolutely impossible without breaking changes. So the answer is no plans. And if you have some specific scenarios, please feel free to put it in discussions. We really do like to hear about that, and then folks will think about it more. And if somebody comes up with a plan that says this is how we could do it without breaking changes, and in particular, the scenarios help us because I'm not that familiar with the Flutter Dart scenarios, and if there are subsets where we could make it work, then we need to really understand the boundaries of those subsets.
Next question is, any chance to have discriminated unions in C# 12?
Well, chance? There's always a chance. We care about discriminated unions. Bill, have you thought much about discriminated unions?
Me? Not a lot. And because this to me gets to kind of a philosophical thing to some degree. If I like the fact that C# and F# have slightly or even massively different personalities in some ways. And mildly flippant, but real answer is if discriminated unions is really, really important to the way you write code, you should write it in F#. They're already there. And that, well, I mean, that's, if that is one of your key things, you should write that library, in that language. And I admit that's a little flippant, and I don't really mean that to say that I'd rather we didn't put them into C#, but more to say I think there's other things I'd like to see more, maybe.
Well, I have my own opinions on this question,
and you should share them.
And so this is honestly probably the question I get asked most. I'm on a few communities, not Twitter actually, but I am on Discord and a couple other C# communities. And this is probably the thing that comes up. The single most request I ever get is, Fred, when are you going to put C# unions in? Please come on. And I really want them. I like unions. I think they're extremely useful especially when combined with pattern matching.
Mm-hmm.
They are one of the most powerful ways to get succinct pattern matching in. So I would like to see them. There is definitely a philosophical question of what do you mean by union? Because there are at least 3 or 4 different types of union that we are talking about adding to C#. So for example, you could have sealed type hierarchies a la Scala. where you can say, all right, I have a base type, and I think Java's adding them as well. You have a base type, and you have some non-infinite bound of subtypes, right? So you have base, and you have 3 derived types, and that's it. That's all that exists. So when you match on something of type base, you know that it can only be one of 3 things. And when you've handled that, you've handled everything. That's type 1. There's structural unions. So those are things like TypeScript, where you can say, I have this thing that is either an A or a B. It doesn't have a name. These are anonymous. They could be implemented in C# via a different method, potentially. But the general concept of type unions is, in that sentence, is somewhat hard. Shush, kitten.
That's the
We
third
actually
type.
can't hear the cat, so I'm sure it's annoying you, but it's not annoying me.
He's yelling, asking for me to pay attention to him, and I'm busy. And then there's the third type of union, which is the value type unions. These are more like C, except safer. Also known as tag unions. Rust is actually a very good example of these, where you have some just chunk of data in memory, and you identify the values in that chunk of memory via some tag. And that's basically a struct union, or a class union, or an anonymous union. And those are the 3 main types of unions we've been talking about. And we have lots of different
None of those sounds like the F# union to me. Isn't that the fourth?
Pretty sure F# is hierarchical classes.
Behind the scenes, but
Behind the scenes, yes.
But it doesn't, from a language perspective, I don't think it acts like that.
Sure.
So I think that from a language design perspective, I'm going to let you finish, then I'm going to comment.
Yeah. So we've had customers who've asked for all 3. And so one of the things that we want to do right now is figure out which of them, maybe all, maybe none, that we want to add to C#, how we want to implement them, and how we want to make them performant, and then, ship a preview.
Yeah. So on this question of how hierarchical systems come out feeling in the language, one way to think about that is, would you want it to feel like we allowed you to have data associated with enums, or would you want it to feel like we allowed you to limit what you could derive? Basically, a new kind of seal that says we're done. No one can ever, in this set that I've got in this state, say assembly, in this boundary, which might well be the assembly, that's all the types that can ever be created. Nobody can derive a new type from this. And that's a different feel from a language point of view. F# is kind of more in the first camp. But as we look at using F# as a model, there is this key thing about F# unions, which is the most common F# union is an option. And an option is a way to handle null, the nothing, what's a null in C#. And so it's not clear how we would associate if we bring options in, then we have options and nulls doing the same thing. And so we also have to resolve how that is sensible, because we know some people will want to use an option because it's a very effective thing in F#. It reduces, there is no null reference exception in F# because of the use of option. The other big thing it's used for is result and piping things. And for that, that is my number one ask for C# style coding, where option, I don't think I want to take option in as a replacement for null handling that we have today. So yeah. Did anybody have any follow-up on that for us? I don't see anything there. But yeah, we individually, we all think about unions. We've had a few proposals that have been made, and nothing has yet caught as this is the right C#-like way to do this. Do you have anything else on that before we go on? Okay. What's our next question, Fred?
Next question is, what this user sometimes finds the inconsistency between methods and properties annoying, where you have to use parentheses sometimes, and then sometimes you don't, and it can feel arbitrary in cases.
Yeah. So I can so relate to this as a Visual Basic. With Visual Basic is one of my background languages. In Visual Basic you don't need the parentheses, and so this is it's clear. In C#, I think we're pretty far down the road that without the parentheses, it means something, and it means that you're accessing the method group. So it's hard to imagine that in C# we would be able to remove them. Do either of you have a different opinion on this one?
I think that's definitely a technical reason why it would be hard. And I think that's one answer. Another answer I think has to do with an idea behind C# in terms of properties versus methods. If you think, if I'm designing a type and I add properties to it, I would expect, especially the get accessors for those properties, to perform more or less like a field access. I don't expect a lot of work to take place. I don't expect a lot of time to take place. I don't expect resource allocation or a lot of things like that. It should, because when people are reading that property access, it looks like you're getting some data, and it looks like you're just reading a variable. Whereas if I am writing a member that does a fair amount of work, maybe it's allocating new structures, maybe it's async and it could take a while and I have to get a task back, or maybe it's just compute intensive and it's going to take a little time. By making it a method, that signals to callers that this could be something that is compute intensive. So I think there's a readability thing there by trying to distinguish those two when you access them. And by playing by the rules, by saying, all right, if I write this thing as a property, it means here's the data, it's there right now. And if I write this as a method, it's like I'm doing some work on your behalf.
Or at least I might be doing some work on behalf. There's
Right.
a couple of comments in the chat, and an example I think on this is count, which count can be fast. Sometimes it's super fast, and sometimes it's not. I have a perf thing when I show off the profiler that I use, and it's simply the difference between string.count, open close parents, and string.length. And
Right.
if you do a lot of those, that will hurt you. That can be, and in the particular example that I have, which is contrived, it goes from like 17 seconds to 2 seconds. It's a tenfold increase. So, it can be quite profound. So I think that is a really good point on that. Are we caught up on our questions?
No, we have another one.
Okay, and then we'll go through, we'll have plenty of time to just list off what you can see in preview 3 if you haven't had a chance to download it yet. Switch off exceptions. Ouch. Ooh. Okay, remember, resiliency is one of our things. I'd love to hear either here or in where you could put more color on it in the discussions on C#Lang, why you want to do this and where you think it's a really good idea, and why the a catch block with the try block with a catch that just swallows the exception is not going to do the job for you. Sounds terrible.
Yeah, on error resume next is not considered one of the highlights of Visual Basic.
What? Oh.
On error resume next is not considered one of the highlights.
No, but this I think is a little different than that. It's not necessarily.
Basically, if you want to ignore exceptions, the existing ceremony is try with an empty catch block. That just catches exception and continues. And I don't think we should be making it any easier.
Now, I will say that if the problem is skipping exceptions in the debugger, now that you can do. You can say don't stop on these exceptions. So it's really important to know that if there's a specific situation, there may be a separate answer for that. And for the debugger, there definitely is a different answer to it.
All right.
Okay.
We have another. We have several new questions now.
Good. Love it.
Yeah. So, ever thought of making structs inheritable? This actually kind of gets back to discriminated unions, because struct inheritance has some problems, namely shared values. So if I have a struct of base type, right, and I have it as a local, that means it's on the stack. And if I allocate a struct of base type or of derived type on the stack, okay, it takes up 5 bytes of data, let's say. It actually that's horrible. That's not a multiple of 4. It takes up 16 bytes of data. It was just hurting me. It takes up 16 bytes of data. Great. The base type for that, let's say it only took up 8 bytes of data, and I pass it to a method that takes one of these base types. Well, now I've sheared half the struct off, right? Because the method took as a parameter 8 bytes of data, not this derived type, which is 16 bytes of data. And so you get into lots and lots of and Mauricio, no, we're not sharing any screens right now. You get into lots of very questionable areas of struct shearing. But discriminated unions, if you implement them as a struct, could be considered a form of struct inheritance, because not all of your discriminated union arms are going to be the same length, because you might have some properties that are shared among all of the struct values, then you might have some specific struct values that have additional ones. But that's a very complicated topic.
It would seem to still risk the
My
same
bad.
problem if you passed the parent into a method, and then the method was going to do the further pattern matching. So it seems like we would still have an awful lot of work to do to make that scenario.
Yeah, the main idea there is that you have to make the parent as big as the largest potential subchild in order to avoid struct shearing, which then means you can't inherit across assemblies.
And that would also affect any time you even think of boxing or unboxing with any interface type. Because you got to put the right thing into and out of the box.
Yep.
Yeah. To be honest, I've never thought about it. Okay, so I will go that far. I've never thought about this, and obviously, these folks have some technical. We do tend to do this. We'll think of something and go, "Oh, these would be the problem." Our job is to think about the problems so that they never show up on your machine. So yeah, we tend to be a little. Every single thing that comes in, we tend to be negative about, even things we dearly love. So yeah, I'm not. I wouldn't be on my breath for this one.
Yeah.
What's our next one? Because if we're gonna do anything on Sharp 11, we're gonna
This.
Okay. We talked about this, kind of, didn't we?
Well, I didn't. I don't think we explicitly. This is roles and extensions.
It's one of the things
we just didn't say the word extension properties. The idea with the extensions part of roles is that you can do extension everything. So you can add extension properties, you can add extension conversions, you can add static extension methods. Like you can extend anything and everything.
All right. We have a couple great questions coming. So
Yeah, I love the next one.
You want to take that one?
Sure. So I think you can already do most of what you want, if I understand the question correctly, which is in C#, if you declare a record, the compiler generates, the methods you're talking about, toString equals get hash code, and I think a copy constructor and so on. If you provide an implementation of any of those, the compiler respects that and doesn't write one. So if you want a different toString, you can do that. You can even in a base record, you can make a sealed toString, and then even derived records will not create a new one. Which I don't know if that agrees with exactly what your last part is. If you want the defaults but a primary constructor, I'm not sure exactly what you're getting at there. The primary constructor is only for those properties that you declare as positional parameters. So you can mix and match those as you want to, I think. So I think we can do everything that the F# record attributes do. It's just done in a different way.
Yeah. And I will also say that in terms of attributes to control this type of thing, we did heavily consider it. We thought about, okay, Do we want to allow you to specify the version of the way string comparison works? Do we want to allow you to specify to use sequence equality instead of whatever the default equality is for your nested lists or whatever? And we came to the conclusion that this is very quickly going beyond what we can reasonably accomplish in a language feature. There are so many ways to customize equality for any particular thing, and we don't want to get into the business of making a language feature that can be used with every single equality thing. We think that is a much better place for a source generator. And so a source generator to generate two-string equality, because those source generators can actually like understand what is a list. The C# compiler has no idea anything about the implementation details of almost every type in .NET. Like it doesn't know how list equality works. It doesn't understand string equality. But what a source generator can do is it can know all of these details, and it can provide all the little customizable switches to support this framework and that framework, and the things that the C# compiler just can't reasonably do. So we did think about that.
I think C# is handling this in a C# way. And we're not trying to make these languages the same. That is no place in the goal. And the things that C# uses as tools are inheritance and in generation. And whether the generation is submitted by the compiler, we'll look to see if you have a two-string, and then we won't if you did, or a code generator that you run. We know that there's still growth to doing code generators. We've not finished with them yet. I'm going to suggest that before we do another question, I run through just the list of what's in Preview 3. So somebody who's wondering whether or not this is the time that they should grab it and take a look will know what's coming there. This is in addition to the features that there's a blog post out right now called Early Peek at C# features. This is in addition to those. So there's raw string literals, super fun feature. If you do JSON, you will want to look at this feature. It makes doing JSON literals easy. UTF-8 string literals, which means if you're using UTF-8 today and you're creating byte arrays by hand, I'm so sorry, you won't have to do it anymore though. Yay. And I believe we will have by the time we get to November, I believe that we'll have an analyzer that will fix that for you, a code fixer. Checked user-defined operators is something that we realized in doing some static and interface and generic math work that was going to be needed. I'm not going to go deeper into that right now. Instructs, auto default. So previously you had to set everything in a struct. Now, if you don't set it, we'll set it to the default. You had to set everything in a struct if you created the constructor. So, or you had fields that you were initializing. So it could be really a pain. And we have a new feature that's coming later called field or semi-auto properties. And when that feature comes in, it will not play nice with you having to do your own initialization. Two more real quick. Switching spans with constant strings. I mentioned that. That just is a new pattern for span and read-only span. And then we have a performance feature where we're caching some delegates that we weren't previously caching. And that's Preview 3. So blog post should be out Monday, cross my fingers, so you can find out more about all those things then. All right, so let's get back to questions.
So any considerations to adding something like variadic type parameters?
Yeah. I would love to do this. This would be fantastic. And I don't think anybody knows how to do it.
It's very different. The way that C# generics work is very different from, say, type templating in C++, where C++ does monomorphization, which is basically it compiles different versions of a thing for every instantiation, and C# kind of shares a lot of stuff. It's a hard problem. I certainly would like to add it, but it's a hard problem.
We ran into this for system command line, and I mean, there's overloads we want that we're afraid to do because it means we have 40 more overloads, or not, it's, I think it's 20, but it's a lot more. And there's a complex way you have to, whatever top limit we put, you may break it for a system command line, because there's very long parameter lists when we're looking at understanding options. So I would love to see this, and I think right now the only way to get there is via source generation. And we are looking, we're doing some stuff there, playing around with source generation to solve this problem. But it's a super real problem for some people, and so I can really sympathize. I just want to say, I know how bad your code is. If you need this, it's really bad what you have to do to work around it, because you have T1, T1 and T2, T1, T2, T3, and you keep going until you run out of patience. So yeah, that one's tough. Anything else? Oh, we have 6 stars with 6 queued up. Oh my gosh, let's go.
Yep. Yes. To follow up on this one, yes, that's the point of extension. That's the point of extensions, is that you can extend static. You'll be able to do things like our next question: implement interfaces on types you don't own. Now, how exactly that will work, that's something we're still trying to figure out. But it is something we're thinking about. We don't really know how we're going to do it yet, but we are thinking about it.
This is work that we're looking at as part of roles and extensions, which we're just starting to talk about, and we're not ready to. We don't even have a solid proposal on this yet, so definitely not C#11, and we're not sure after that.
Yeah, and to as someone said in the chat, yes, it is type classes. This is basically turning interfaces into type classes. If you're familiar with them in Rust, they're traits. If you're familiar with them in Swift, they're protocols. So the idea is that you could implement IEnumerable on this thing that you don't own, or you could implement the upcoming static abstract methods, the upcoming generic math off on some other thing that you don't own. And there are some questions that we need to answer, like, for example, the way that Rust works, it has what's called an orphan rule, which means you must own either the type being implemented on or the interface you are implementing. And that solves some type system problems that we're going to have to think about how we want to solve. But that's the general idea. Rapid fire went through 2 real quick.
Let's go next.
Yeah. So Kathleen, is there a right place that you should go if you want to talk about the design of C#?
CSharpLine Discussions. CSharpLine Discussions, #1 place, because it's discussions, so it's threaded. We can have conversations much better than GitHub issues for that. And although if you have something concrete, issues are a possibility, but we would encourage discussions. We think that's the best place to talk. Thank you for putting the link up. That's totally awesome. And yeah, so we super look forward to all your conversations about dreaming of fancy futures very fancy futures for C#.
Yeah. All right.
You said we had a lightning round. We've got 5 queued. Oh my gosh. All right, 5 minutes. Okay.
Gotta go real quick. Struct delegates. This is something that a few of us have been thinking about, actually. Jared and myself. This is, so again, on the C# Discord, if they're not asking me about unions, the low-level channel is asking me about when they're going to get struct delegates. And I know Sergio is listening, and I know he's going, value delegates. So this is something that we've definitely thought about. And in particular, I think that once we get ref fields, which is something that we're planning on adding in C#11, that we might be able to do something here. But combine ref structs and ref fields and some CLR black magic, and maybe you can get allocation list link.
Yeah. Awesome. Now we can hear the cat.
That wasn't me.
My cat in the background.
And my dog's going crazy in the background. So if you hear
No, that one's mine.
finished, you can wait.
All right. Okay, so why can't you use switch expressions as statements? Is I think the answer to this what this question is asking. And I'm not entirely sure. There's two potential ways to take this question. I want to be able to use the new syntax because I think switch statements are terrible because they're from C. Or I think the other way to view this is I want the exhaustiveness of switch expressions. We do have proposals around both of those, about how we could modernize switch expression syntax or switch statement syntax, and we have proposals around how could you make switch statements exhaustive. But the general thing right now is a switch expression is an expression, so it needs to evaluate to a value. Statements do not need to evaluate to a value, which is why there's that distinction.
Yeah.
All right. Okay. Next one. Now we have 2 minutes and 4 questions, 3 questions, 4 questions.
This one's so related to the last one, and
It is.
it's interesting. We run into this with the standard as well, because we have to. If you look at the standard, we have things like expression statement, which is basically an expression that's really a statement and doesn't return anything because it's void. And having a type there would solve both the previous question and this one. For what, in that now we have a type of expression that returns nothing. I don't know how much it would.
.NET though, deep. It's deep baked in. This is the yeah.
I'm not sure.
You don't think so?
I mean, I think.
I mean,
conceptually, I'm not sure. Implementation wise, it could be baked in so deep it's really scary. But
yeah. So void. I mean, .NET itself is statement based.
Mm-hmm.
F# did paste over all of that. Where F# is entirely expression based, and you do have to use a unit type. There's many places this is painful, and func in action is one of them. Where if you're making overloads that T1, T2, T4, if you have a void and a not void, you just made double this already big mess that you had. Yes, it is definitely painful.
Well, and so where I'm looking at where I think there's things that could be possible here is we've done it like with, say, throw expressions now. What does a throw expression return? It doesn't.
Yeah.
Right.
Yeah, that's true. That's true.
But it means we can put a statement where it should be an expression.
Speaking of things that should never return, we have considered a bottom type or a never type before. We've thought about it. It's not at the top of the list, but it's something I would like.
Yeah. All right. So have we caught up on questions?
No.
No, they keep coming.
All right. Let's do a couple more. We'll run a few minutes over, and then we're gonna stop at 5 after. Is that okay with you?
Yeah, that's fine with me. That's fine with me. Code generating engine. Let's just take this real quick. Yes, we know that the current string-based is hard to do. We've currently been investing in getting the general experience of using source generators up to where we want it to be. The next thing to do, hopefully, is going to be making generators easier to write. We have a few ideas on how to do that, but that's where we're at right now.
I'm the PM for source generators as well as languages, and so feel free to reach out. I have a little bit of history in source generation, so I feel like we have some opportunities here. I'm also personally would love to see us do magic and let there at least be one option that is cross-language for VB and C#. Mm-hmm. So it won't be F# as well. F# does things in a different way. But reach out. What I'm saying is reach out if you. And the discussions, you can tag no discussion in CSharpLine if you like.
Mm-hmm.
I like regions.
No, I can take this one.
I'm the only person at Microsoft, I think. No, that's not true. I really like regions. I just want to make that statement, and then we can go on, and you all can.
Yeah, I don't want to rabbit hole on that in of itself.
What?
Rather than rabbit hole on that, I can say this from a docs perspective. I really, really, really try never to write, oh, you should never use this. And there's probably 3 reasons for that. One, Kathleen and Fred both kind of talked about this, how high the backwards compatibility bar is. So no matter how old something is, it's still supported and it still probably has valid uses. And if you have code that uses it, there's no reason to get rid of it. A good example right now is I'm writing about rostering literals right now. And, if you want my opinion on what I'm going to do in the future, I'm probably going to use that almost always instead of trying to remember to double quote and how multiple braces get parsed and string interpolation and escape this and everything else. But I'm certainly not going to recommend that people rip it out of their code, because I think that's counterproductive and not worth it. And that's true of a lot of features where we look at things now and we go, this newer feature is probably a better way to do what you were accomplishing with this older feature. Because, again, as Kathleen mentioned earlier, we learn things as we keep going through versions. But something we don't want to do, even with something just like recommendations, is split the C# community and say, well, this is all legacy stuff you shouldn't use. This is what we do. This is what good developers do. But there is a question of, if I were teaching C# from scratch now, getting to Phyllis Noble's one in related question in chat, what would I teach first? And we have this natural tendency to teach things in historical order. That is what I'm really trying to break with this idea that Mads talked about with modern C#, which is, if I were teaching someone who's never used C# how to write code today, I would not teach Lambda functions by saying, well, so here's a method and here's how you create a delegate and here's how you assign it to something. And then now you can do it with like an anonymous delegate, and now you can write a Lambda. And I think that's important to help people learn things quickly and get up to speed more quickly. But that's a very different statement than saying, well, if these things are in your code's bad and you should get rid of them. So we're really trying to kind of balance that very, very carefully.
So we're actually probably not going to use the phrase modern C# because we think we can't do it without a connotation of this kind of good and bad, when actually what's working for you is what's good. And so we do want to have guidelines for docs, how we write our docs, the way that we choose there to do code. And as an implication of that, that's something we'll just do internally. We're trying to figure out ways to communicate, kind of your greenfield and, or your learning, which things are better. But it's really more good and better as opposed to don't use, which was, I think Sergio was the one who asked that question. There are some things you should not use. There's some array list. Don't use array list. And I do think we should do a better job of taking the handful of things that we kind of wish that we could. I don't think we deprecated array list. I mean, that's the non-generic object only, list.
Nope.
And so there are a few things that at least, I would be willing to say, yeah, I wouldn't use this new code. But there's not actually all that many. So you think about properties. There's several ways to do properties. Actually, they're all valid. It just depends on your scenario.
And even to the regions point, we use regions in docs a lot because the parser that we use to build the static site, that's how we can extract, or one of the syntax elements that we can use to extract, I want to show just these lines of code. Yeah. So it's got its valid uses.
And I think we have time probably for one more question.
All right. Do we have one more?
We do have one more. Well, we probably have several more, but there was one more I wanted to.
We have to go, I think.
Yeah. Which is back to roles. So TypeScript interfaces or duck typing in general. The previous name for the roles and extensions proposal was shapes, and shapes allow you to define a shape that the type didn't have to implement, and it kind of just implicitly was this thing, and then you could pass it around as just a shape. And in general, in C#, we aren't huge fans of nominal typing like this. So we kind of.
You said nominal typing.
Oh, sorry. I said nominal. I meant structural. I did mean structural typing. There are a few places where we kind of have to do it, particularly because we don't have type classes. And I think that if we had like for each, for example, we're using, someone else brought those up earlier. And I don't think if we had type classes from the beginning and you could implement for eachable, and for each has some other problems, other performance problems where we want to use duck type, where we want to use structural typing for it. But if we had more nominal ways of solving that in C#, I don't think we would have a structural matching system.
Yeah. So I think languages wind up with these core realities. They're just really deep and baked in. And C# are really tied to .NET, and then other things are tied to where they are. Nominal typing is kind of deep in C#. So we don't want to do something to C# that starts fracturing it.
There's a couple other parts that this leans into. One is there's a design philosophy in C# that the compiler should help you find bugs as much as possible, right? Rather than the runtime. So if something's not going to work, if we can tell you it's not going to work when you're compiling, that's better than telling you it's not going to work when it runs. And then related to that is we actually want compilation to be fast enough that you'll still do it. Right. And structural typing is one of those things that can get hard there. And there are places the language does it. The query expression pattern is structural. The awaiter, the generalized async types is structural. I think there might be one or two others. For each, as Fred mentioned.
Using for ref structs.
Yep.
Because ref structs can't implement interfaces.
Right.
All right. So, I think we may need to call it.
Yep.
The questions like on dynamic and all, bring us back. Man, we got in some super fun with all these questions here. I want to thank everybody who brought questions today. It makes for a fun time. And I won't be here next month, but some other folks will be here. And we will be doing the stream. And I want to thank everybody
a lot of fun.
for coming and let everybody say goodbye. So, Fred, anything you want to say in closing?
Yeah, you can find me on the C# community Discord, and I'm 333 Fred usually on there, unless there's some sort of name meme going on, in which case I'm whatever the current name meme is. But yeah, always happy to answer questions.
And you can find me on Twitter at Bill Wagner, or just add any comments on the docs on things that we should be addressing that we're not.
All right. Well, thanks everybody for coming, and look forward to seeing you in the future. Enjoy the rest of your evenings, days, nights, whatever time of day it is for you.
Right.
So long.
Yeah.
Mm-hmm.